In this video, you will learn on how to compute the horizontal asymptotes. Horizontal asymptote is basically a line where y equal to b and b in this case is a constant of our function. To find the horizontal asymptote, you have to check limit of x approaches positive infinity or limit of x approaches negative infinity of your function. As long as you get any constant as your final answer, we can conclude that that constant is basically your horizontal asymptotes. For this, we only have one step. So, find the value of x approaches infinity, and our aim is to get a constant as our final answer. Let's do some exercises. So for example 14, we have to find the horizontal asymptote if they exist for the following function. Part A, we have fx equal to 2 over 3x minus 2. So this is basically our function. We just have to do x approaches negative infinity of 2 over 3x minus 2. Now, just directly substitute the limit value into the limit function. You will get 2 over 3 times negative infinity minus 2. So, you will get 2 over negative infinity as your final answer. As you learned before, whenever you encounter constant over infinity, your final answer would be 0. Now, perform the same step for limit x approaches positive infinity of your function. Directly substitute, you will get 2 over 3 times positive infinity minus 2, and you will encounter 2 over positive infinity. As before, whenever you encounter constant over infinity, your final answer would be 0. Since for both tests you get the same constant value, we can conclude that y equal to 0 is basically horizontal asymptote for your function. Proceed to part B. We have function x squared minus x over x cubed minus 1. So, limit of x approaches negative infinity of x squared minus x over x cubed minus 1. If you do directly substitution, you will encounter the case infinity over infinity. And this is known as indeterminate case. You have learned this before. Whenever you encounter infinity over infinity, try to simplify your function by divide your highest power of denominator. So, now we try to manipulate the function by dividing all the terms by the highest power of denominator. In this case is x cubed. So, every single term in your function will be divided by x cubed. So we will have x squared over x cubed minus x over x cubed over x cubed over x cubed minus 1 over x cubed. After that, try to simplify your function. Now, you will have a simplest version of your function of limit of x approaches negative infinity of 1 over x minus 1 over x squared over 1 minus 1 over x cubed. After that, once again, try to substitute the limit value into your limit function. So you will have 1 over infinity minus 1 over infinity divided by 1 minus 1 over infinity. As before, whenever you encounter constant over infinity, this can be simplified as 0. So your case will be 0 over 1. So your final answer in this case is 0. Now, just perform the same step, but we have to do for x approaches positive infinity of our function. Every single step would be the same. Basically, in this case, so I just copy it back. Limit of x approaches positive infinity of x squared over x cubed minus x over x cubed divided by x cubed over x cubed minus 1 over x cubed. And then once again, you simplify your answer. So you will have limit of x approaches positive infinity of 1 over x minus 1 over x squared over 1 minus 1 over x cubed. Now you can directly substitute the limit value. So you will have 1 over infinity minus 1 over infinity over 1 minus 1 over infinity. Constant over infinity can be simplified as 0. So your answer would be 0 over 1. In this case, this is equal to 0. Once again, for both tests, you get the same value. So we can conclude that y equal to 0 is the horizontal asymptote. This is basically how to represent your asymptotes on your graph. So basically, in order to sketch the asymptote in the graph, you have to use a dotted line, as you learned before in topic 5. I repeat, in order to sketch your asymptote in your graph, you have to use a dotted line. In this case, you can see that basically for horizontal asymptote, you only have the value of y. And for vertical asymptote, you only have the value of x.